Hello, friends. Welcome to Physics with Ben. Don't forget to subscribe, like, comment, and share this video to those that need it. In today's class, I want us to look at a brand new topic, scalar and vector quantities in physics. Without wasting more time, let us go straight to the business of the day. So, what are scalar quantities? What are scalar quantities in physics? Scalar quantities in physics are defined as those physical quantities that have only magnitude or size but no specified direction. Example Examples of this quantity include mass, we have length, we have speed, we have distance, we have temperature, we also have energy, etc. Next up, we want to look at how these scalar quantities, are added or subtracted. So write addition of scalars of scalar quantity. Scalar quantities are added using simple algebraic method. They are added using what we call simple algebraic method. What do we mean by simple algebraic method? For instance, let's suppose a town, a vehicle moves from town A to town B and then finally to town C. So the distance covered is represented with this. Let's suppose from town A to town B, the vehicle covered 20 kilometers. From town B to town C, the vehicle covered, let's say, 17 kilometers. So they may ask you to find the total distance covered by this moving object. You don't need any special arithmetic here. It's just simple algebraic method. So the simple thing is the distance from point A to point B plus the distance from point B to point C. So we write that the total distance is simply 20 plus 17 kilometers, and that will give you 37 kilometers. As simple as ABC. So these are how vectors and scalar are added. We call this simple algebraic method. Next up, we are not discussing much on scalar quantities in this class. Our emphasis are on vector quantities. So what are vector quantities? Vector quantities, right? Vector quantities are defined as those physical quantities in physics that have both magnitude and also a specified direction. Examples of vector quantities. Examples of vector quantity include displacement. We have velocity. We have acceleration. We have force. We have linear momentum. etc. We have plenty of these examples. For the sake of this class, these are the ones that we have. You can search them and get more of them. So the next thing we want to look at is how these vectors are represented. How do we know that this is a vector? How do we know it? So we write vector representation or representation of vectors. Representation of vectors. Right. Vectors are represented with arrow-headed straight lines. They are represented with arrow-headed straight lines. They are represented with arrow-headed straight lines. What do we mean by this? If I draw a straight line like this, and then I put an arrow, I just represent a vector. For instance, the symbol for acceleration is A. In advanced textbook, you see A with an arrow on top, meaning that A is a vector. The symbol for force is the F, capital letter F, uppercase F. And if you see an arrow on it, telling that is a vector. The symbol for velocity is V. So an arrow on top indicates it is a vector. So these are some of the symbols that represent vectors. Now this line, the length of this line from this point to this point represents the magnitude of the vector, the magnitude or size of the vector. Why the head of this arrow represents the direction of the vector. That is what we mean by arrow-headed straight line. Next up, we want to look at addition and subtraction of vectors. Addition and subtraction of vectors. Good. We said scalar quantities are added using simple algebraic method. How about vector quantities? Vector quantities are added or subtracted using simple geometrical method. They are added or subtracted using simple geometrical method. Good. Now, what do we mean by simple geometrical method? What do we mean by this? What do we mean by this? Good. This simply tells us the direction in which the vector is acting. We now tell us how we're gonna act, how we're gonna find the summation or the the difference of the vector. Now, A, by simple geometrical method, we mean that if two vectors, let's suppose f1 and f2 are acting in the same direction, you find the resultant vector f by just saying f1 plus f2. Good. B, if two vectors, let's say f1 and f2 are acting in opposite direction and you want to find the resultant vector in magnitude and in direction, then the resultant vector f becomes the longer vector, which is f2 in this case, minus, this is your f1, minus the shorter what vector, the vector with the largest magnitude minus the vector with the smallest magnitude. That is case B. How about case C? Case C says if these vectors are acting at right angles to each other, let's say this is our f2 and this is our f1, then to find the resultant vector, you have to apply Pythagoras theory such that the resultant vector f, becomes f squared is equals to f1 square plus f2 square, so that your f becomes the root of f1 square plus f2 square. Let's look at case D. We are still discussing the simple geometrical method of adding vectors or subtracting vectors. Case D says if two vectors are acting at an acute angle or are acting at obtuse angle with each other. This is your f1 and this is your f2. This is your f1, this is your f2. Then in this case, we can find the resultant vector in magnitude and in direction using the cosine rule or the sine rule. The next thing I want us to look at is the resultant vector. We are going to look at this in details in the next video. we want to look at what we call the resultant vector. Examiners may ask you to define the resultant vector or find the resultant vector in a question. How do you define the resultant vector? We define the resultant vector as follows. The resultant vector is defined as that single vector which would have the same effects in magnitude and direction as the original vectors acting together. A simple analogy of the resultant vector here is this. If two forces, F1 and F2, are supposed to drag this object and move it in this direction, and then if one single force can still do the work of F1 and then F2, then this single force F is called the resultant vector because the force is capable of doing that which F1 and F2 can do. Next up, I want us to look at the methods of finding the resultant vector. Methods of finding the resultant vector. There are basically two methods of finding the resultant vector. These methods are: 1. Using the parallelogram. Using the parallelogram method. Method 2. Using the triangle method. Good. So in our next video, we are going to concentrate on using the parallelogram method.